Okay, today we're doing Module 4, Exponents and Exponential Functions, F.LE.1, Level 2 Reteach. Write the recursive and the explicit formulas for each of the situations. So first of all, I'm going to determine if it's an arithmetic or a geometric sequence. So I see it's 0.5, 9, 3. So this one definitely, I know A1 is 19.5. I would say it's a common difference that it's going up by 0.4. So the recursive and explicit. So I'm going to write it. The recursive always means you write the first number and then you put a semicolon, and then you're going to write A of n, and then I'm going to write, now with arithmetic, it's more like a distributing thing. So we're going to write A of n minus 1, and I'm going to put plus 0.4. Now, the explicit formula, I do A of n equals 19.5 plus 0.4 times n minus 1. Taking a look at the next one, I see 3, 9, 27, and 21. So A1 is 3, but this one is geometric because we're multiplying it by 3. So the recursive formula for this one would be A of 1 equals 3. And then this one is more of a multiplication, and we have that as an exponent. So this 3 is times 3. It's up there as like an exponent. And then my explicit formula would be A of n equals 3 times 3. And then this is my exponent n minus 1. Taking a look at the next one, I see A of 1 is 4, and it looks like I'm multiplying by 2, so r equals negative 2. So again, it's going to be that exponent. So we got r, and we're going to have A of 1 equals 4, and then I'm going to do A of n equals a n minus 1, and then I'm going to put times negative 2. And then my explicit formula is A of n equals 4 times negative 2, and then this would be n minus 1. Taking a look at the next grouping. So the next grouping, I see that it's 13, 14. There, it looks like it's arithmetic. I know A of 1 is 127, and my D, or common difference, is 13. So R, and then I'm going to have A of 1, and that's 127. And then I'm going to do A of n equals a n minus 1 plus 13. And then my explicit formula is A of n equals 127 plus 13 n minus 1. Oh no, fractions! Whoa! Okay, so this one, we know it's A equals 1/4. And it looks like 1/4, it looks like I'm dividing by a half. Dividing by, not a half, I'm dividing by 2. So R equals 2. So now I'm just going to go R equals A of 1 equals 1/4. And then I'm doing A of n equals a n minus 1. And then I'm going to put times 2. Now my explicit formula is A of n equals 1/4, because that's my starting. I'm going to put 2, and remember, this is your exponent, n minus 1. And the last but not least of this section, we have A of 1, which is negative 14. It looks like I am decreasing by 5, so a minus 5. So we know it's arithmetic. R equals A of 1 equals negative 14. And then we'll do A of n equals a n minus 1 minus 5. And then my explicit formula is A n equals negative 14 minus 5 a n minus 1. Now let's take a look at this. So I am looking for the 43rd term of 1. So I'm going to go up to 1. And the formula that I always use is the one with the E. I always use the explicit to solve anything. So I'm going to take this, instead of n, I'm going to put in 43. So I'm going to do a of 43 equals, and I'm going to put in 19.5 plus 0.4, and I'm going to do 43 minus 1. A of 43 equals 19.5 plus 0.4, and that's going to get me 42. 43 minus 1 is 42. Then A of 43 equals 19.5. I multiply these, I get 16.8. And A of 43 equals 36.3. Taking a look at the next one. So I'm using number 5. And I always use the explicit formula. The recursive formula doesn't do it, but I want the 9th term. So for me, I'm going to do A of 9 equals 1/4 times 2, and I'm going to do 9 minus 1. So A of 9 equals 1/4 times 2 to the 8th power. I've always told you that you always want to do this first. So 2 to the 8th power would be A of 9 equals 1/4, and 2 to the 8th power is 256. Now in this case, I can actually do it. Sometimes I don't even clear it, and then I multiply by 1/4, and that would get me A of 9 equals 64. Taking a look at the next one. So we need to write the explicit formula for each recursive formula. So recursive formula, so we have to write an explicit formula from each recursive. So we know that this is my starting, so that's going to go A of n, and I start with that number 5, and my rate, or my common difference in this situation, would be +3, and then I do n minus 1, and I'm done. Now, this is geometric, so again, I start with my A of n, and I'm going to start with 8. My ratio is this one, so 0.88, and remember, it's n minus 1. So now we're doing the opposite, the recursive to each explicit formula. So we need to figure out what the first value is. So A of 1, we know that this is arithmetic, so A of 1 would be 5, and then you do your semicolon. And then I do A of n equals, and then I'm going to do A n minus 1, and my common difference would be +2. This one is geometric, so we know that the first term, A of 1 for this one would be 2400, and then I'm going to write A of n equals A of n minus 1, and then I'm going to make this up here times, and I'm going to put 0.91 as my exponent. Thanks for listening, and have a great day.